Today let us look at similar triangles. Let us recap. If we take a triangle and zoom it out to make a smaller triangle, we see that the angles of these two triangles are the same. We know that the sides of similar triangles are also proportional. Now let us superimpose the vertex A onto vertex B. Now let us look at the criterion for similarity of triangles. We can see 6 conditions here. One, that the angles are all equal, and the second, that the sides are all proportional. But we don't need all of these to be true for two triangles to be similar. The first that we just saw is the AAA similarity, or angle-angle-angle similarity. So if the angles of two triangles are equal, then we call the two triangles similar. There is another called AA similarity. In this case, only two angles of the two triangles need to be equal. The third angle would be automatically equal, as sum of angles of a triangle is 180 degrees. There is another type called the SSS similarity. So if the corresponding sides of two triangles are proportional, then by the SSS similarity, we say that the two triangles are similar. There is also the SAS similarity. So any two corresponding sides of the two triangles need to be in proportion, and the included angle needs to be equal. So there are 4 criterions for similarity of triangles. We could use any one of these to say that two triangles are similar. Let us look at a few problems. In the given figure, QR by QS is equal to QT by PR, and angle 1 is equal to angle 2. Show that triangle PQS is similar to triangle TQR. So let us first look at our diagram. We can see an isosceles triangle PQR because angle 1 is equal to angle 2. This implies that the sides opposite to these equal angles would also be equal. So PQ would be equal to PR. Now let us look at the ratios that we are given. So we have QR by QS is equal to QT by PR. That looks weird. Well, we already know that PR is equal to PQ. So let us write PQ in the denominator. Now this looks better. Now instead of PQ, let us write QP. We see that they are corresponding sides of two triangles now. So recall the two triangles that we are trying to prove to be similar. Yes, they are corresponding sides of triangle PQS and triangle TQR. So we have two sides of these two triangles. Now all we need is an included angle. We see that the angle 1 is common to both the triangles. So by the SAS similarity, the two triangles are similar. Let us write the names of the two triangles as triangle PQS is similar to triangle TQR. Let us look at another problem. E is a point on the side AD produced of a parallelogram ABCD and BE intersects CD at F. Show that triangle ABE is similar to triangle CFB. So we have a parallelogram and we are producing the side AD to a point E. Now let us join BE and let it intersect the side CD at point F. Now these are the two triangles we are going to prove to be similar. So let us look at these two triangles closely. We know that ABCD is a parallelogram. So let us look at angle A and angle C. They are opposite angles of this parallelogram. Hence, they would be equal. Now another property of a parallelogram are parallel sides. So the opposite sides of a parallelogram are parallel. So let us take any one pair of the parallel sides. Let us take AB parallel to CD, and we see that BE is the transversal here. Now can you spot any angles that would be equal? Yes, angle ABE would be equal to angle CFB. They would form the alternate interior angles. Now let us look at the other pair of parallel lines, AE and BC. Once again, BE is the transversal. Can you spot any equal angles here? Yes, angle AEB would be equal to angle CBF. Once again, they are alternate interior angles. Now look at the green and blue triangles. We have just proven that the corresponding angles of these two triangles are equal. So triangle ABE is similar to triangle CFB by the AAA similarity. Let us look at another problem. Sides AB and AC and median AD of a triangle ABC are respectively proportional to sides PQ and PR and median PM of another triangle PQR. Show that triangle ABC is similar to triangle PQR. Let us first draw the two triangles along with their medians. Now since AD and PM are medians, they would divide the sides BC and QR into equal parts. Now let us look at the proportions that we are given. We know that AB by PQ is equal to AC by PR is equal to AD by PM. Now they don't form the corresponding sides of the triangles ABC and PQR. If instead of AD and PM we were given the third side BC and QR, then with the side proportionality, we could have proven that the two triangles were similar. But that is not the case. So we need something extra here. Let us recall our tricks. We could join diagonals, but there are no diagonals to join here. Or we could draw perpendiculars. But dropping a perpendicular would merely give us a right angle. There isn't any other property that we could apply. That leaves us with the third choice, that is to draw parallel lines. So let us draw a line parallel from the point M. We could draw it either parallel to PR or PQ. Let us draw MN parallel to RP. And similarly DE parallel to CA. Now, recall that there is a midpoint theorem. If we are drawing a line from the midpoint of one side such that it is parallel to another side, then it divides the third side in equal parts as well. We know that PN would be half of PQ and EA would be half of AB. Let us multiply both the sides by 2. Also, we know that MN would be half of PR. Similarly, DE would be half of AC. Once again, due to the midpoint theorem. Now, let us multiply both the sides by 2. Now, we see that AB and PQ are appearing in the first equation. We also see that AC and PR are also appearing in the first equation. Let us substitute the values and put them equal to AD by PM. Look at these sides now. They correspond to the triangles AED and PNM. And we see that the sides are in proportion. So we can say the triangle AED is similar to triangle PNM due to the SSS or side similarity. But what does this give us? This gives us one angle. We see that angle 1 would be equal to angle 2 since the two triangles are similar. Now we could also draw lines parallel to PQ and AB from the point M and D. And in a similar way, we could prove that angle 3 is equal to angle 4 by proving that the two smaller triangles are similar. Do you see what is happening now? We can add statement A and B. And this gives us angle P is equal to angle A. And now we have something interesting. Let us look at the proportions that we were given once again. AB by PQ is equal to AC by PR. They form two corresponding sides of the two bigger triangles. And we have just proven that the included angles, angle P and angle A, are also equal. So by using these two, we could say that triangle ABC is similar to triangle PQR by the SAS, or side angle side similarity. This question is a little tricky and needs a little foresight to understand what are we trying to prove. We had two sides of both these triangles, but we needed an included angle, and we used the midpoint theorem to prove that.